Okay, here is question number 2 on that same solving equations review worksheet. Question number 2 is a little bit different than questions 1 and 3 in that we're not necessarily trying to solve these equations. The goal of the exercises in question number 2 isn't to solve the equation, but it's to identify whether these equations are one of 3 types, right? So the 3 types of equations that we're trying to kind of work with here, the first one is called an identity. Okay, the second one is called, not a conclusion, but a contradiction. Started to write conclusion, but I meant to write contradiction. And the last one is a conditional. Okay. So those are 3 categories of equations that we will be confronted with over the next few months as we solve all different types of equations. So with these linear equations, let's see, the first thing we want to do when trying to determine what kind of an equation we have, and we'll talk more, of course, about what those equations actually are in a second, but I want to simplify it, right? So I want to clear parentheses and combine any like terms that I possibly can. If I do that, I'm going to get 4k minus 5 equals 4k minus 6, right? Yes, plus 1. Okay, great. Now, if I were trying to solve this equation, of course, what I would do is I would subtract 4k from both sides, because I'd be trying to get the like terms all together. But you notice if I do that, if I take a 4k away from here and I take a 4k away from here, all the variable terms disappear, and all I'm left with is constant terms. Okay. If I combine like terms over here first, what I'll notice is, let's see, negative 6 plus 1 is negative 5, right? Okay, if I just leave it like this, what you notice is on the left side you've got 4k minus 5, and on the right side you've got 4k minus 5. Okay. Now if we were to try to solve this equation, in other words, figure out what values for k can be substituted into this equation and such that you get some kind of a true statement, well, anything you put in for k will work, because it's exactly the same thing on both sides, right? So when you end up in a situation like that, where the stuff on the left is exactly equal to the stuff on the right, okay, where there's an infinite number of solutions, okay, the type of equation that is, it's called an identity. Okay, an identity is an equation in which everything on the left side is equal to everything on the right side. It's got an infinite number of solutions. Okay, geometrically, what's going on here, of course, is this right here. If we were to graph it, this is the equation of a line, and so is this, right? They're exactly the same line, right? The graphs of either side of this equal sign lie right on top of each other, right? They're exactly the same identity. Okay, I've said enough about that, I think. All right, so what else do we have here? Let's see. Do the same thing where I clear parentheses. It's going to be 2b minus 8. And over here there is nothing to do. Just gives me 2b minus 7. And again, like before, I notice if I do the next move where I try to combine the variable terms, I'm going to subtract 2b from both sides, but all the variable terms will then disappear. Okay. That maybe makes me think, oh, this is another identity. However, the difference here is what you have on the left is not equal to the stuff on the right. Okay. The constant terms are different. Okay. So what's going on here? What's going on here? Well, I suppose we can see one way of seeing what's going on here is if I go ahead and subtract the 2b's from both sides, what I get is negative 8 is equal to negative 7, which of course, is never true. No matter what you plug into this equation for b, negative 8 will never equal negative 7. We followed all of the rules for solving equations. We didn't do anything dicey or sketchy, okay? And we ended up with a conclusion that is, it doesn't make any sense, right? So what we have here is what we call a contradiction, okay? Contradiction. In other words, there's no solutions, okay? Okay, and I suppose what I should say up here with this identity is there's a infinite number of solutions. Okay, infinite number of solutions is an identity. No solutions is a contradiction. Okay. Again, I'll say something about the geometry. I kind of like to think about it not just in terms of the algebra, but in terms of the geometry. The geometric representation, okay, if you were to graph 2b minus 8, is a line with a slope of 2 that has a y-intercept of negative 8, right? On the right side, the geometric representation of 2b minus 7 is also a line with a slope of 2, so these two lines are parallel. But the y-intercept over here is negative 7, okay? Same slopes, different y-intercepts means those lines will never intersect. If the lines never intersect, then there is no solution to that equation, okay? All right, last one here. So I guess by process of elimination, the hope would be that this last one is a conditional. We'll see what happens. No parentheses to clear, so I don't have to do that. The variable terms are different, so looks like I'm not going to end up with one of these situations. 3x minus 2x is just x plus 7 equals negative 5. Oh, okay, this is just like your basic subtract 7 from both sides, x equals negative 12. So this equation here has one and only one solution, okay? In a situation like this where the equation has, well, if an equation has one solution, it's definitely a conditional equation. Okay. Conditional equation is an equation where it has solutions, okay, but the number of solutions that it has is not infinite, okay? That's important for when we solve other kinds of equations in the future with like quadratics and other kinds of things. Sometimes equations have 2 solutions, or 3, or 4, right? As long as the number of solutions isn't infinite, and it's more than 0, right? It has at least one solution, then at least one solution, not an infinite number of solutions, then what you're dealing with is what we call a conditional equation, okay? All right, so that's part 2 of this solving equations review. I'm about to do number 3. I gotta erase this and have some more coffee. Probably gonna open a LaCroix too. I'll see you then.